Hello, welcome to today's video. I hope everyone is doing okay today and through this time off. Let me know if you need anything at all during this time. It doesn't have to be math related. Just let me know if you need anything. Kind of like yesterday, people sending pics of what they did outside. I'll just keep that up. I know I'll send some out too. I think it brightens everybody's spirits. Um, in that remind post, we can post about movies we're watching, TV shows we're watching, games we're playing, any kind of activity that'll help us out. I think keeping in touch will be good for everyone. Now, with that said, let's get to the point of the video. And I've had a lot of questions about activity number 6 or task number 6, and that is converting those distances. All right, so let's take a look at that. All right. On the first one, it does ask us to, let me get this set up. It does ask us about, make sure I got this right. There we go. The distance from, like the first one they have us do is the help center to the water slide. So I have a little setup here. And on my graph paper, I have them set up here. So it doesn't really matter where you have them on your paper. You'll have to do this for all of them anyway. And I do want to figure out the distance on the paper, how many squares that's going to be. And that's going to be, using the distance formula or the Pythagorean theorem, since we have graph paper. We've done that quite a few times in our FIM. But before we do that, it does tell us in the worksheet here that we are given land that is 301 meters by 196. Oh, that must be miles, right? Meters. Well, it can't be miles either. We'll call it meters. So 301 meters and 196 meters in size. So what we have to do, it says, first thing we want to do is count the number of spaces along the length of your paper. So when I do that, I'm going to ignore this little tiny gap here. I'm just going to count the nice squares I have. And I'm just going to count that distance. I believe this on this paper is 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20. Yep, it is 21. So from good square to good square, that's 21. All right. So my number, my distance along my length is 21. If you have, not little kid graph paper like I have for Henry, but actual graph paper, your number is probably going to be quite a bit larger. But this one's 21. And then if I go back to the worksheet, that's kind of this thing right here. Count the number of spaces along the length of your paper. So for mine, it's 21. All right, and it says set the ratio equal to blank spaces per 301. So that's 21 spaces for 301 meters. All right, sorry, that's a little blurry. Let's see if I can fix that. There we go. Okay, so we have this set up, and you can see it's still a little blurry, but I don't know if there's much I can do. There we go. Okay, so that is going to be our ratio, and we've done this quite a few times when we're setting up proportions, and that's exactly at least how I think to do this problem. So what I'm going to do, and I mean, we could figure out. I know many of you have like if you've done this to completion, you have your x and y axis on your graph paper, and you probably have an ordered pair for this and an ordered pair for the water slide. And you could use the distance formula that way. But since I have the graph paper, I am just going to count the distance down and the distance over. And that will give me my length of my right triangle here and my width of the right triangle. And then I can use that to set up my Pythagorean theorem or even just the distance formula. Okay. So if I count down 1, 2, 3, 4, 5, 6, 7. So that length is 7 here. And then I count over this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my width of that triangle is 10. Now I can set up the Pythagorean theorem or even the distance formula, really, where it's, and I'm just going to kind of do all my work in here. Okay. So it's 7 squared plus 10 squared, and that's the square root of. And that's kind of our distance formula, right? Now, if I had ordered pairs here and I subtracted the y's, I would get 7. And if I subtracted the x's and square, I might get 10. Dang, it keeps going in and out of focus. So that ends up being 49 plus 100. I'm going to square root that. That's 149 square root. And if I put that into my calculator, I'm going to get 12.2. Okay. And so that is the distance, at least square-wise, across. Okay. So if I can kind of draw that out, the distance from the water slide to the help center is 12.2 on the paper. Okay. And if we know that we have that space of land, we can use that proportion we just said. So our proportion is, on our paper, 21 is 301. Okay. And we're going to set that equal to 12.2 over x. We don't know it. That's going to be the actual distance. All right. So I'm going to get my calculator out here. And I'm going to cross multiply to solve this. So I get 21x, didn't have to do that part, equals, sorry, 12.2 times 301. And that gives me 3,672.2. Hey, you can't see that either, can you? There we go. So I set up that cross multiplication. Now I'm going to divide both sides by 21. So I'm going to just take my calculator, divide by 21, and I get 174 meters. So x equals 174 we could say 0.9 meters. All right. So on my, I guess I could have showed my work here. Sorry. On my distance from the help center of the water slide, after all this work we put on here, okay, we found the distance, the actual distance. We set up a proportion. This number will always be the length, or how many squares you have on your graph paper, over 301. And then this number here will always be what you got for the distance on the paper. Okay, so 12.2 squares. And then I set up a proportion, I cross multiply, and in this case I got 174. So that 174.9 meters would be how I would get the distance from those two objects. All right, sorry about the video going in and out as far as focus goes. I don't know if that would have helped, but anyway, and that's exactly how we do it. One thing about this whole project here that I kind of thought about while we were watching a show is if you have Disney Plus, or you can get access to it, on the Imagineers, they talk about how they set up Disneyland in California, and how in the middle is the main attraction, and then all the other attractions kind of spoke out like a bike. And if you wanted ideas on how you could set up your water park here, and that might be a way to do it, where you could put your main attraction, or maybe even just your help center in the middle, and then all your other attractions kind of stem from that, and then you'd have a kind of like Disney World, which I thought was kind of neat. But it was on the first episode of Imagineers, if you're interested. Might be something to do while you're bored. So anyway, oh, we'll be upside down that way. There we go. Again, I hope this video helps. If you have any more questions, I'll make more about this project. But I think the rest is pretty much, very much review of the things we had. I thought this was going to be the trickiest part. So good luck. Again, let me know if you have any questions, and we'll see you guys next time.